So this problem starts off with a little story from my past. So I'm going to take you back to my 11th grade year. I was taking trigonometry and studying for my ACTs. So I was working really hard at this math and some of the science portions, and one of the study questions in the study guide was very similar to this homework problem. It was about someone staring out from an unknown place in this building towards a monument, and the monument was huge. In this case, let's just say the monument is 500 feet. Now, from eye level, it is straight across the exact distance from the person to the monument, which actually is what this problem is going to ask for. It wants to know how far is the person to the monument. And we're going to then basically state that this distance x along this straight horizontal line from here to here is what we're going to measure for the distance. So I really worked hard with this problem because I could figure out that this is a right triangle and also this is a right triangle, and I've got one of the angle measurements here, and I can find the third angle measurement, but I feel like there's a lack of information here. For example, I know for a fact that this is not 250 and 250. I can't be guaranteed to be staring directly at the center of the monument. And also that would be impossible because then this angle moving up, or the angle of elevation, would be the same as this angle going down, the angle of declination. So there's no way that this is 250 and 250, and without a proper side of the triangle, I kind of felt the problem was unsolvable. So what I did is I asked a good friend of mine who was smarter than me. He took a lot more math and science than I did by his junior year, and asked, hey, how do I do this problem? And she said, oh, well, I mean, it's just the tangent of 15 degrees, and you add the tangent of 3 degrees, and you divide the sum of that from 500. And I was like, what? You just take the two angles, the tangent of the two angles, add them together, and then that becomes your denominator, and your numerator is the height of the monument? And she said, yeah. And I was like, I was totally confused, and I did that process, and she was like, absolutely right. And because I checked, the study guide, and I just asked her, just kind of in awe, how'd you know how to do that? And she says, oh, it's like a pretty easy trick in physics. It's a very common problem, and that's what I remembered for the long time. And I'm not sure if I ever saw that problem again on my ACTs, but I remembered it as something like, wow, that's a cool trick. But I really need to explain why taking the tangent of 15 degrees plus the tangent of 3 degrees and adding them up and making that your denominator, with your numerator being the height of the monument, why does that work? And it seems like it came from out of nowhere. So I want to kind of show you this. This is a classic problem that I think the people who created this homework assignment wanted you to get exposure to, because it's just one of those kind of old problems from trigonometry and possibly from your physical science class that you might have had to do. But let's kind of break it down. First of all, let's talk about tangent. Tangent, according to SOHCAHTOA, is opposite over adjacent. And that's key right here, because the opposite side is, let's say, this y distance here. So this is, let's say, y sub 1, and it's the distance along this part of the triangle. Okay? So that's y sub 1. So the tangent of 15 degrees is equal to y sub 1. Okay? Now, we're going to change colors a little bit, and we're going to look at the tangent of 3 degrees. Okay? Now, again, we have not talked about our denominator here yet, but you're going to see how that denominator is kind of important here, because here's our tangent of 3 degrees, and its opposite side is y sub 2. Okay, so it's y sub 2. Okay, so now what I'm going to have, since tangent is opposite over adjacent side, okay, so I'm going to color that red there, you can see that these both have a denominator of x, okay? So here I have the tangent of 15, which is y sub 1 over x, and the tangent of 3, which is y sub 2 over x. And now this, if I decide to add them together, because look, I have common denominators here, then those added together is going to be y sub 1 plus y sub 2 divided by x. Okay, so that's y sub 1 and y sub 2 divided by x. Now x is actually what we're trying to find, which is pretty sweet, right? But you'll notice that y sub 1 and y sub 2 is actually the height of our monument, which is 500, okay? And I can set an equation, I can set this left side and right side equal to each other by, because the x, as long as I have common denominators, you know, I see I have this x down here. So this y plus, so you can see that the numerator here, y sub 1 plus y sub 2 is 500, and x is equal to x. So this is a true equal statement. But what I just highlighted in yellow is actually the tangent of 15 plus the tangent of 3. So now I can change this left-hand side to be the tangent of 15 degrees plus the tangent of 3 degrees is equal to 500 over x. Now, through the power of cross multiplication, I can go 1 times 500 and tangent of 15 plus tangent of 3 times x. But a cool thing we can do, this is a rule and it's okay, you can do this for cross multiplication, is we can switch the positions of one of these diagonals. So now on the left hand side I've got x over 1, and on the right hand side I've got 500 divided by the tangent of 15 degrees plus the tangent of 3 degrees. So that trick that I was told by my friend how to do the problem works out perfectly, but it takes a little bit of thought and manipulation to actually get to taking that 500 and dividing it by the tangent of 15 degrees plus the tangent of 3 degrees, or your angle of elevation plus your angle of declination. So make sure when you do this problem on your calculator that your calculator is in degree mode. Click on the mode key and make sure that your calculator is set to degree. If you have a physical graphing calculator, it won't actually switch back, but sometimes with virtual calculators and iPhone apps, they will switch back to radian mode once you turn them off. So I go to second mode to quit to a clear screen, and I'm going to take my height, I'm going to divide it by, and I'll put parentheses for good programming. You got to put the parentheses in here or else it's not going to work out. The tangent of 15 degrees, and close it off there, plus the tangent, oops, don't want to put my parentheses there just yet, tangent of 3 degrees, and put 2 parentheses at the end. And that gives me my answer. If I round that to the nearest whole number, it's 1,561 feet. That is how far away I am from the monument. So I want to thank my wonderful students who asked this question, and for the fantastic student who built this wonderful picture. And yeah, I just wanted to expose you to that problem, and hopefully that makes more sense. I know you may not have thought about solving it this way, but it's good to kind of see this classic problem here. And I see already that I should probably round that up to 1,561 feet away from the monument. Well, thank you for watching.